welcome to the elevator acceleration problem. So our question here is, what is the acceleration of our elevator? We only have a few tools at our disposal. So we've got here this scale. This is an electronic scale. It can measure in grams, ounces, or pounds. I'm going to use metric, so we're going to stick with grams, and we'll have to translate that into kilograms. But I'm going to need to use my scale. I need an object, so I'm going to go ahead and use my keys. They're somewhere, I think they're in my pocket. Okay, I'm going to use my keys as the object. And then I'm going to need data recording equipment. So I've got paper, I've got my pen, and I am ready to go. So what we're trying to do here is figure out what the acceleration of our elevator is. And we're going to utilize Newton's second law to try to figure that out. Now, Newton's second law is a little bit more drawn out than this, but we're going to remember it together as F, the force, is equal to m times a, which is mass, times acceleration. So the force is equal to mass times acceleration. So why I need my scale is to be able to measure my mass. When my object is sitting stationary, I know the acceleration of gravity. The acceleration of gravity, or gravity's acceleration, is equal to negative 9.81 meters per second squared. And that is how we're going to use this as kind of our foundation and draw on that. We'll do a little bit of thought experiment together. So what we're going to do is we're going to go into the elevator together and do some measurements for our data collecting. Okay, so here we are. We've got our scale. We've got our data measuring devices, which for me is fairly simple because it is just a paper pad and a pen. And we've got our object, which is a set of keys. So what I'm going to do is I'm going to turn this scale on. Now, this is not going to be a very accurate measurement of the actual mass of my keys. So I'm going to put this on this electric balance here. I know I called it a scale before. It's technically measuring mass. So the mass here of my keys, it says while it's sitting at rest, is 71 grams. Okay, so I'm going to make that measurement there. I made sure to zero it out so that I knew that my recording was accurate here. But actually, it would be okay, but we don't need to talk about that. 71 grams is where we're at, okay? So that's sitting at rest, no acceleration. Now, I'm going to accelerate twice to get some kind of a data point, okay? Normally, you would do a trial more than one time and then average your numbers together. So I'm going to go ahead and hit the accelerator on this elevator. It's going to send me up. And when I start moving is when I feel acceleration. Because remember, acceleration is a change in velocity, is a change in velocity. So when I'm slowing down or when I'm speeding up, either one of those is going to be an acceleration. So here we go. Watching this here. Okay, and I got up to 85 gram reading. Now, my keys did not magically gain any mass when I started moving. So I know that the increase is actually an increase in acceleration or in force. Okay, so what I'm going to do is I'm going to go back down and take one more measurement here.
Way back down to the bottom, door opens.
Thought I was going to get stuck in here. Okay, so the door's open now. It's going to close in just a second. That way nobody has to wonder what the weirdo is doing in the elevator. And then we're going to do this one more time. I'm going to take another data reading. So again, what I have right now is I have down that we had a 71 at rest, 71 grams, and then 85 grams when we first started accelerating. And remember, my keys did not gain any mass, so there must have been some sort of an acceleration that caused a force to push down, okay? Accelerating again, starting now. Okay, that time it only got up to 83, okay? So I've got 85 and 83. I'm going to go ahead and average those together. The average of them is 84 grams. That gives me my data points to go ahead and begin trying to calculate here the acceleration of my elevator. Okay, so as we continue on with trying to understand how it is that we're going to calculate the acceleration of our elevator, we have to ask some questions and maybe do a little bit of thought experimentation with this. One of the first questions I would ask is, did our keys gain mass? The answer to which we've already discussed is no. My keys did not gain mass. I know that force is equal to mass times acceleration. And my scale here, my balance, it read a stronger force, right? The force that it felt at first was the force due to weight. The object, my keys, were being pulled on by gravity at negative 9.81 meters per second squared. And so it was feeling a force. But then when I started moving upward, the keys resisted that movement. They didn't want to go up, and so they pushed down a little bit harder, but not only due to the weight of gravity, but it also has to do with the pushing up underneath of it. Okay, so we have this pushing from down below, and that is causing a greater force up above. But my measurement was taken in mass. Right? So if I'm going to do this correctly, I'm going to calculate in kilograms. So I had a resting of 0.071 kilograms. Okay? So if that's my mass, 0.071 kilograms, and my acceleration due to gravity when it's at rest, remember, is negative 9.81 meters per second squared, then I can calculate my force by simply multiplying my mass times my acceleration, and that is going to be negative 0.70 newtons. Negative 0.70 newtons. That's the force that was felt on this scale because of my 0.071 kilogram keys. They're being pulled down at negative 9.81 meters per second squared. Then when I started to move, the scale measured a new mass. And the new mass that it measured was 84, or 0.084 kilograms. The question is, was that the new mass of my keys? The answer, of course, is no. So if my scale was feeling a force of 84 grams, or 0.084 kilograms, it could be a force of how much? Like, let's imagine for just a second, so this is a thought experiment. How much of a force would it have felt if it was not moving at all? So it measured 0.84, acceleration due to gravity is negative 9.81 meters per second squared. And I don't have my calculator here with me because it's right up there on the phone. We're going to imagine that's around 0.82 newtons. Okay, let's just go ahead and say that, negative 0.82 newtons. So that was the force that it would have felt if the mass was really 0.084. And remember, it was not, but we could imagine that for just a second. So if it's feeling a force of negative 0.82 newtons, and my mass continued to be 0.071 kilograms, the question is, what is my acceleration? So this was kind of my thought experiment here. It felt this. If this was the acceleration, then what is the force? Well, the force would be roughly 0.82 newtons. So if the force that it's feeling is 0.82 newtons, okay, if that's the force that's being felt by the scale, and I know the mass is 0.071 kilograms, then what is the acceleration? Well, now it's really easy. Now it's just algebra. I have force is equal to the mass. Force is equal to the mass times the acceleration. I can just plug in that variable and solve my acceleration problem. So I hope that that helps you a little bit. If you're not quite sure how to get to understand this force here, how did we calculate this force here? Again, remember, we did a little bit of a thought experiment and imagined, well, my scale felt this weight. It felt this force, this weight. And so if this had been standard and we had normal gravity and I wasn't moving anywhere, this was the acceleration, then this would have been the force. that would have been pressing down. So if this is the force that's pressing on the scale, and it is the force that's pressing on the scale, but I know that my mass is not this, my mass is this, then what is the acceleration? So good luck on your journeys, and I hope you have a good weekend.